Hello everyone, today I want to share some knowledge regarding the adaptations in the Hillstream fishes. Here is the introduction. A large number of rivers, streams and lakes are present in the hills and their ecological conditions are quite different from those in the water bodies found in the plains. A number of teleostean species live in the hill streams and rivers can be divided into two groups. In number A, those which migrate off into the hill streams for a specific purpose such as spawning and live there temporarily. So these species do not exhibit special adaptive features. In number B, species that are permanent inhabitants of the hill streams and rivers and possesses special adaptations to suit the peculiar environmental conditions of the region. Here is the origin of the Hillstream fishes. It is accepted that in searching for food, the fishes living in the sluggish water of the rivers of the plains gradually migrated off into the hill streams. In Hillstream, plenty of food is available and there is no competition, and also predator fishes are absent there. These species gradually develop organs for adhesion and other adaptive fishes suited for life in the fast-flowing streams of the hills. Some species like Gyptothorax, Gara, and the Pseudogenesis become highly specialized for life in hill stream. Here is some picture of the hill streams. Some important hill stream fishes. Species of Teleus commonly found in hill streams belong to the following genera. Family Caesaridae. In family Caesaridae, Gyptothorax, Gyptosternum, Pseudogenes, Ithritis, etc. Such kind of fishes are found in the hill streams. In family Cyprinidae, Barbus, Ortor, Lavio, Gara, Schizothorax, Barilus, Alitora, etc. In the family Covitidae, Botia, Almorea, Nemacellus species, etc. In the family Hymalopteridae, Hymaloptera brucei. In family Chanidae, Chana gochoa is found in the hill stream. Conditions found in the hill streams. Most of the hill streams have only the return zone and the Potamon zone is absent. The fishes living in these areas shows interesting modification for adaptation. Here is the return zone. Most of the hill stream fishes found in this area and also found in this in this area. Return zone is here. The water current in the hill stream is generally very rapid and strong. The fishes living in those streams develop various mechanisms to withstand the swift current. Water in the hill stream is well aerated and plenty of dissolved oxygen is available. Water is clear and the streams are shallow. As a result, bright and intense light is available throughout the day. Plenty of food is in the form of algae and insects. Insects include mayfly and stoneflies, etc. are available in the hill streams, but plants cannot grow due to the fast water current, and the food consisting of worms and crustaceans is scarce. Fishes can find protection and shelter under the stones and rocks. Only small sized fishes are found in the hill streams. Modification found in the hill stream fishes. All the fish species living in the rivers and streams of the hills do not show significant modification for adaptations. Fishes like Gyptothorax, Pseudogenesis, and Gara species develop highly specialized structure, but species of Lavio, Schizothorax, Nemacellus, Barilus develop less specialized structure. External body shape. Their external body shape. Many hill stream fishes possesses dorsoventrally flattened body, which seems to be leaf-like structure and highly Example: Gyptothorax, Gyptosternum, Pseudosenesis, Balitora, etc. Their dorsal surface is slightly arched and the ventral surface is horizontal. Their head is semicircular and small in size. Hillstream species possesses cylindrical body where the water current is fast. Example: Torputitora. Generally, Hillstream species are in small size, which enable them to take shelter under the stones and live easily in shallow water. Their scales. Some Hillstream species have well-developed scales as exoskeleton found in the tortoise, but most of the fishes have reduced scales. Very minor scales are embedded in the skin in species such as Schizothorax, Nemacheloch, etc. In some species, small scales are present on the dorsal and the lateral sides of the body but are greatly reduced and even may be absent on the ventral surface. The species do not have scales on the dorsal surface anterior to the dorsal fin, as in the Gararosicus and the Gara abovi. Scales are absent from the ventral surface where adhesive organs are present. Their mouth and lips. Hillstream fishes' mouth is usually shifted to the ventral side of the snout and not transversely opening at the anterior end. Their mouth is semicircular or crescent shaped, having thick lips and the strong jaws to help in scraping food from stones. In Nemacheloch, the lower lip is divided in the middle and the lips are swollen, forming a ring-like sucker. Balitora, the lips are produced into several tentaculate processes and form an effective sucker. Here you can see. In Hymaloptera, the lips are thick and tuberculated to provide sucker-like attachment to the stones. The lips of the Gyptothorax and Gyptosternum are reflected and spread around the mouth and so forming a sucker-like structure. Barbels. Their barbels are reduced in length, short and stumpy, thick and fleshy base, having the striation or tubercles. This provides additional surface for attachment to stones and rocks. Example: Gyptothorax, Gyptosternum, etc. Pair fins. The outer ray of the fins become thick and flat and develop striation or ridges to facilitate adhesion to rock and stones. The position of the pair fins are shifted outwards horizontally along the sides of the body to facilitate in adhesion. Their pectoral fins show higher and better specialization than the pelvics. Caudal fins and caudal peduncle. Their caudal peduncle is long and narrow, which is adaptation for life in fast flowing water of the hills. In many species, the lower lobe of the caudal fin is longer than the upper one. Example: Gyptothorax striatus, Gara, Gotila, etc. Their eyes. Generally, their eyes are reduced in size and situated on the upper surface of the head close to each other so it can keep a close watch on the surrounding environment with larger vision. Another main reason for reduction in size is due to intense and bright light reaching the fishes in shallow clear water. Example: Balitora, Brucei, Pseudosenesis, sulcatus. Gill apparatus and branchiostegial rays. Generally, their gill slits are reduced in size and present along the sides of the body because the ventral surface is modified and used for attachment. Their bronchial chamber is small and the passage for water is reduced, so the respiration is difficult when the fish is attached to stones or feeding on the algae. This is compensated by the higher oxygen content of the Hillstream. The fish can retain water for a longer time in the bronchial chamber due to the small size of the gill slits. The inner rays of the pectoral fins are continuously moving to force the water in and out of the gill chamber, helping the respiration. The pectoral fin itself is vascular, having numerous blood capillaries, thus serving as an accessory respiratory organ. Due to the backward shifting of mouth and reduction in the size of the gill openings, the bronchiocecal rays are reduced in number. Here is the bronchiocecal rays you can see here. Air bladder. Hillstream fishes living in shallow water do not need air bladder as a hydrostatic organ, so air bladder is considerably reduced or degenerate. Instead of air bladder, two small lateral chambers joined with each other by a narrow tube which is found in the cryptothorax and cryptosternum. Thanks for watching. If you like the videos, please subscribe this channel.